We'll proceed in the vector field, very important and probably the most recent, and that is something that is more developed in the calculus. So we will try to enter into parameterization of the vector as far as vector field is concerned. Okay, so if calculus you are genius, then in calculus battalion, in calculus archaeology, in calculus group of islands, then we have something called vector field. Vector field, you are genius, you are awesome. So calculus is a game of algebra. So if you know algebra very well, then something that you can do really very good in calculus means it is yours. So calculus belongs to a person who is very good in algebra. So anyway, now if I know I am very good in vector, so vector is a kind of energy which has a direction, and since it is energy, then certainly it has magnitude. So magnitude plus direction is a vector. Algebra algebra is nothing but it's a function of independent variable. Algebra is a function of independent variable. Means if I consider any C function or Pascal function, okay, then it is something like it has a parameter list. If I pass the independent variable, if I pass the parameter variables in the function or subroutine that is called in Pascal, so if I pass the parameter, then internally it does the computation and returns a value. That is algebra. Algebra is a black box which has input line as independent variable. If you pass the value of independent variable inside that, it would do some computation and then it would return a value. Algebraic function, algebraic equation is nothing but algebraic function. Function is nothing but a kind of algorithm which takes independent variable, does some computation and returns a value. A function equal to function over independent variable x and y is x square plus y square. That is equation of parabola. So if there is a algebraic function that is x square plus y square, then this proves that function fxy is x square plus y square. If inside I don't worry about the function equation also. If I know this function does computation for the 3D paraboloid, then I pass x and y as parameter to the function and it does some computation, that is x square plus y square, and returns the z value or fxy. So a vector has a direction and magnitude. Typically vector, if we see the vector, then vector is combination of many vectors. So if I have a vector that is 2i plus 3j plus 4k, the way it is written plus plus, this proves that it is combination of three separate vectors. 2i means there is a vector 2i. 3j means there is a vector 3j. 4k, then there is a vector 4k. If it is 2i, this proves that a vector is moving along x-axis I and has a strength of 2. If this is origin, then this is 2i going along x-axis. If this is origin, then it is 3y, 3j going along y-axis. If it is origin, then it is 4k going along z-axis. If they combined, all three combined together at origin, coming from this direction, coming from this direction, coming from this direction, if they combine at origin, then they one energy three energy got combined to one energy and they flow in a certain direction. Okay, that certain the new direction is now it is noted, it is kind of denoted new vector that is formed with the combination of three vector is denoted as 2i plus 3j plus 4k. What is power of this vector? If these three vector has power 2, 3 and 4 respectively, then what is the magnitude power of new vector that is formed? Then it is not 2 plus 3 plus 4. If because the vector they got combined together, they are orthogonal to each other. If they are orthogonal to each other, then they would follow Pythagoras theorem. So magnitude of new vector is 2 square plus 3 square plus 4 square square. So this is the analogy of a vector. If I have a vector 2i plus 3j plus 4k, then what is this vector's presence along x-axis, y-axis and z-axis? If there is a wind or there is energy moving in direction of 2i plus 3j plus 4k, then how much energy is sensed along axes? Then 2 along x-axis, 3 and 4. Okay, so that is something that is vector analogy. Now new terms come that now suppose in some scenario vector keep on changing as per the x, y, z value. So if I have x-axis, if I have y-axis and if I have z-axis, then the vector equation is xi plus 2j plus xi plus 3j plus 4k, not 2i, xi. If that is true, then at every point, now what is the vector at point 2, 3 and 4? 2, 3 and 4, there is a point coordinate, what is vector there? So that is 2i plus 3j plus 4k. What is the vector at position 4, 10 and 20? That is the coordinate. Then it is 4i plus 3j plus 4k. This proves that x component of the vector keep varying as per the x coordinate. If I have a coordinate, then x component of the coordinate, as per the x component of the coordinate, this vector keep changing. This is vector field. Vector field where each component of the vector is a function over another some independent component. I'm not saying that is independent component is x, y and z. Independent component can be anything. Okay, it can be t also, anything. So I have now I can say it is ti plus t square j plus t to the power 3 k, whereas it has x component as t, y component as t square and z component at t to the power 3. This proves that there is another independent component t. Now there are four things, x, y, z axis, and another independent component t based upon the t. Now x, y and z components are varying. So we can say that x component is function over t, then y component is function over t, then z component is function over t. This is called parametric vector. If it is a function over a independent component t, only one independent t, and that t is not any of the orthogonal axes, this is called parametric vector. But if the x component, y component and z component, if they are function of again function of x, y and z independent axes, orthogonal axes, then it is called vector field. Okay, so vector field is a kind of a vector in the Cartesian coordinate but vector keep on changing if we change the Cartesian coordinate. This is vector field. Like algebraic equation, if I say I have independent component at x-axis and algebraic equation is 5, then y-axis is 5 altitude and there is a straight line. It does not vary. But independent component is x square. Then there is a variation. So at each different x, the y is different. So this is algebraic equation. Or if this is xy plane and this is z axis, then fxy, that is function over xy, that is algebraic equation. If it is x square plus y square, then z value at each independent variable on xy plane, that is x comma y, at each independent component, each coordinate on xy plane, on each component on xy plane, the z value is varying. It is not constant. Z is nothing but a surface, and surface is not flat surface. If surface is variable, this move proves that at different xy coordinate in xy plane, z value is different. These are algebraic equations. But but vector field is that each coordinate xy, at each coordinate, if it is xy plane, then at each xy coordinate there is a vector. Each xy coordinate there is a vector. If these vectors are different at different xy point, then it is called vector field. If I have a algebraic equation, then how I can get the vector field? That is one question. Another is, if I have algebraic equation of a surface, then how I can get parametric vector? Parametric vector is again a vector generating function. If vector field is a vector generating function for different x and y, then parametric vector is also vector generating function, but for different one for only one independent component t. With variation of t, then I see variation in x, y, and z component. So the most basic thing for a curve is algebraic equation. From algebraic equation, can I deduce vector field? From algebraic equation, can I deduce a parametric vector, whatever it is? Now, the question is arising that if I have algebraic equation, then what is derivative of algebraic equation as far as I have one independent component, that is x-axis? Then if it is fx, then what is dfx by dx? So if I say derivative of algebraic equation means derivative along x-axis by default, implicit. What is derivative of a function along any axis, that is u, or any vector, that is u? That is called directional derivative along a vector. So by default it is directional derivative along x-axis. If it is xy plane, then any derivation means derivation against xy plane. I am not talking about x and y. There is one independent component, that is xy plane. Inside xy plane, there is x and y axis as independent component. But if it comes to 3D, then independent component is again only one, that is xy plane. That is matter of research now, that how we can go along with one independent component in 3D. If it is n dimensional, then there is only one independent component, that is n minus 1 plane. If it is x, y, z and alpha, then there is one plane or one volume, that is x, y, z volume. That is only one independent component. Based upon that, alpha is changing. So, but how we can again disintegrate the xyz cube component into surface and z axis, then again a surface to xy axis, that is matter of research. So that if someone kind of cracks into this area, then you can crack the complexity that people are seeing in multi-feature artificial intelligence data set. If it is a artificial intelligence multiple feature, one feature is one component. So generally people go with the feature reduction, okay, and then try to come up with the orthogonal component. Okay, so in those areas, if we want to do a major work, then we have to think about hybrid independent planes, hybrid independent cube, and so on, rather than so many axes. Then those we can slowly disintegrate to the final, the end feature or end the orthogonal component, whatever it is. Now, it is clear that what is a vector field. So, differentiation of a algebraic equation along xy plane, this is what generally we see call it differentiation. Differentiation along x-axis in 2D, this is what generally we call differentiation. Then we talked about directional derivative along any vector. What about directional integration along a vector? Directional derivative we saw. If someone asks me that I have a function, I have a algebraic equation in 2D, what is its integration? It is implicit that integration is calculated along x-axis. If integration is calculated along x-axis, this is what we call it integration. Suppose that instead of algebra, I have vector field. Algebra can be converted to vector field. So instead of algebra, I have a vector field. Vector field is nothing but a vector and algebra hybrid, where each component of a vector field is an algebra. So if I have a algebraic vector, then if I do integration of that vector, then default is along the independent component. If it is 2D, then along the x-axis. What is integration of this vector field along any vector? This is called line integral. Line integral is nothing but integration of a vector field not along the x-axis, along any axis. If that axis is u, then integration of vector field f along u vector. If u vector is not a straight line, it can be a curve, but it has to be a line. If it is a curve and it has a direction, it can be this way direction or opposite direction. There can be only two directions in a line. So if I have a curve, if u is a curve, then u is again a vector field because each point there is a vector. Each point is not a straight line. So what is the integration of a vector field f along a line u, not along the vector u, because u is no longer a unit vector, it is a set of vectors. So what is the integration of vector field f along curved line u? This is again a line integral. Rather, this is the complete line integral. So line integral is integration of a vector field, that is algebraic vector, along a curved line, that is a line integral. So this is what we have seen. Now if I take inside, suppose the vector field is single vector. Vector field is a single vector, okay, not the collection of xyz. Means xyz, all three components of the vector field are scalar. So vector field is a scalar vector now. If it is a scalar vector falling on u and u is again a straight line, then f is a vector field of a scalar single vector. F dot then the u vector. This is what we saw. If I want to calculate the vector field, the integral vector, please watch the previous sessions. So if I have a vector field and then I want it line integral of this vector field, if a straight line along a vector field u, then it is nothing but integration of f dot du. F vector dot d, that is differentiation sign u vector. Okay, integration from first position to second position in the line where I want the integration. If u is a straight line, f is a straight line, then straightforward I can say that integration then f dot u, f dot u, f vector dot u vector, where u has unit vector and magnitude, f has unit vector and magnitude. Now, if f is a pure vector field which has x, y, z functions as component of the vector field, and u is again a vector field which has its x, y component as a function of x, y, then we cannot do f dot u. Then calculus will come in a way that at each point in u is different, f is different. Both are variable with independent component x, y, z. If that is the case, then if things are variable as per the x, y, z, then to calculate the multiplication f dot u, I need calculus. Then at that time, it is f vector dot product of d, that is the integration sign. In integration, we keep d like fx dx. So capital F vector, that is vector field dot d, and then the u vector integration from lower limit to higher. Okay. So something like if this is a vector field, but this is not a straight vector, this vector field will keep changing as per the xy plane. If I take only x-axis, then as x-axis is changing, this will keep changing. This is the vector field. It is function on xy. So this is the vector field and this is the path. This is u vector, u curve line, and this is f vector. But f vector will keep changing all along the u. And u is not a straight line. So if I keep changing xy, then if I take a small strip in the u, if this is a small strip, then here it is a small strip, then a small strip direction keep on changing. It is in this direction here it is in this direction, here it is in this direction. So this unit curve length is also u, or if I call it r, then r is also changing along the curve, and vector field, if it is vector, this is also keep changing along the curve, whatever the algebraic equation. If that is true, then this vector field's line integral along this line is this vector field algebraic equation dot dr. If this is r, then dr integration from beginning point till end point. This is now line integral, the net integration. Now, if I have this r as kind of in a vector, position vector, then how we calculate that we see. So we gave one kind of example. Now, one example we have solved, that if there is a circle, then first quadrant is a line that is going from x-axis to y-axis, and unit length, if it is length is a, then a0 to 0a, if it is going like this, then in that way, if there is a vector field minus yi plus xj, see the last video, we have given one questionnaire. If vector field is minus yi plus xj, and the curve, the line is a circle with radius a, only first quadrant, that is a comma 0 to 0 comma a. If a is radius, then what is the vector field? The position vector of this has equation as xi plus yj, or xi plus a square root of a square minus x square j, being the formulation of a circle is x square plus y square equal to a square. Then position vector, if this is a circle, centered at origin, then first quadrant, the equation of the circle is the position vector of the circle is xi plus yj. If that is true, then xi plus a square root of a square minus x square j. Now this vector is minus yi plus xj. And so the line integral from a comma 0 to 0 comma a is integration of from a comma 0 to 0 comma a. Now f vector is minus yi plus xj dot d dot dr f vector dot dr vector. R vector is nothing but xi plus square root of a square minus x square j, and this side f is minus yi plus xj. Now if we do the dot product, now first we will do, now if it is d of xi plus square root of a square minus x square, okay, it is x square j. If I do the differentiation, okay, it is d of the position vector, so differentiation. Now if I do the differentiation, so if it is, suppose the position vector is xi plus yj, why I change it to square root of a square minus x square. Net integration is integration from a comma 0 to 0 comma a. If it is a circle we are talking about, one end of the first quadrant is a comma 0, other end is 0 comma a. Integration from a comma 0 to 0 comma a. F vector dot product d r vector. R vector is xi plus yj. If I break it d, then it will become dx. Okay, x differentiation, it becomes dx, dxi plus dyj, dxi plus dyj, and here it is minus yi plus xj. If I do dot product, it comes as minus y dx minus y dx plus x dy. Limit from a comma 0 to 0 comma a. Now minus y will convert to a square root of a square minus x square dx plus minus minus a square minus x square, and this side it is dx, so dx plus x dy, x dy. Now dy is nothing but a square root of d of a square root of a square minus x square dx. Then it will convert into minus a square root of a square minus x square dx minus x divided by square root of a square minus x square dx again. Okay, so earlier I had minus yi plus xj and dot dr, r is xi plus yj, that converted to dxi plus dyj. Dx got stick to I component and dy stick to y component. So x component here is minus y. So minus a square root of a square minus x square dx plus x dy. So y is the square root of a square minus x square. Then that if I differentiate, it becomes minus x by a square root of a square minus x square dx. Both are dx now. If that is true, then it comes as minus the square root of a square minus x square minus x by square root of minus a square minus x square dx. If only dx comes into the picture, the integration changes from a to 0. Now if it is minus a square root of a square x square minus x by a square root of minus x, then it will come to, here it was minus yi plus xj. So x, and there dy brings minus xy square root of a square minus x square. This becomes minus x square. So minus square root of a square minus x square minus x square divided by square root of a square minus x square. If I multiply these two numerator, it becomes minus a square plus x square minus x square divided by square root of a square minus x square. So net it would be net it would kind of okay. So net it would become as a square minus a square divided by a square minus x square dx. If that is true, then 1 by square root of a square minus x square dx is sine inverse of x by a. So it is minus, now it is minus a square sine inverse of x by a, that is the integration. X by a, if I put from a to 0, if it is 0, then complete it is 0. Sine inverse of 0 is 0. Now, then if I substitute a, then sine inverse of a by a, then it is 1. So, sine inverse of a by a, 1 means pi by 2. Minus minus gone. So, it becomes a square pi by 2. Okay. So, this is what I am trying to calculate. Okay. Try it on the paper. So, the vector field is minus yi plus xj, and along the circle first quadrant that has a radius a comma 0 and radius a. So, from a comma 0 to 0 comma a. Okay, then it will become f dot dr. R is xi plus yj, and then if I do d, then it becomes dxi plus dyj. Do the dot product. This is our way. This is not available anywhere. And then, because if we proceed through this way, then we can do very tough calculation in the future. And then, so that is the concept that we can do for the, as far as the kind of the line integral is concerned for a circle. Now another is parabola, where y equal to, this is another example, y equal to x square. If that is true, then we have again minus yxi minus yi plus xj dot dr. R is xi plus y. So it becomes minus y dx plus x dy. Integration from 0 comma 0 to 2 comma 4. This is what the assignment we have given. That if there is a parabola y equal to x square, then what is line integral where vector field is minus yi plus xj, where the line is from 0 comma 0 to 2 comma 4. Okay, so it results in minus yi dx. Y is x square, so minus x square dx plus x dy. So y is x square, then d of x square result in 2x dx. So x into 2x is 2x square. So here, so here it is minus y with minus x square, and there it is 2x square joined to form x square. X square dx, okay, minus y dx minus x square dx. X dy, where dy is nothing but 2x. So 2x square minus x square dx. X square, if it comes in dx, then integration from 0 to 2. So x square dx is nothing but x to the power 3 by 3. So this would result in 2 to the power 3 by 3. So it is 8 by 3 is the line integral. Okay, please watch the previous video for the questionnaire that we have already given. Okay, now we will talk about parametric vector. So parametric vector, it is different from vector. If I have algebraic equation, then algebraic equation can be converted to vector. If I have algebraic equation, that algebraic equation can be converted to parametric vector. Parametric vector is nothing but it's a vector, parametric vector, parameter. It's again a kind of a vector which is a function. A vector which is a function of only one independent variable, that is t, and t is not the independent orthogonal component xyz. This is parametric vector. Okay, if y equal to x square, then what is the parametric vector? If position vector is xi plus yj, if position vector, if I say xi plus yj, and if I keep x equal to t, then y equal to t square. Then parametric vector is ti plus t square j. Okay, plus if it passing through some point, then I have to add that point to the vector. If it is passing through point 2 and 4, then 2 it will get added to x component and 4 will get added to y component. So now it is 2 plus t, 2 plus ti plus 4 plus t square j. This is net parametric vector, or if it is passing through 0 comma 0, then no need to add anything. So that is ti plus t square j. Same thing, 2 plus ti bracket 2 plus t bracket closed I plus 4 plus t square j. So this is parametric equation of vector. Okay, if that is true, now consider that I am calculating vector field F dot with dr. Vector field F dot dr. Okay, now R is a vector. R is a vector in terms of x and y. So this is a R curve line where each point is in x and y. Suppose each point is in t, not in x and y. If that is true, if I take any strip, small strip, now I divide it into n different components. I don't like this kind of approximation, but somehow many people understand through this way also. So if I take any strip, if I break into n different components, then any component if I take, then if this is R point, R point at T1, not at R point at any Ti, not at Xi, Yi. So this point is R at Ti, and this is R at T plus Ti plus 1, R at Ti, any I. If this is I is 0 and this is I is n, then at any I, R, if this is R, then R at Ti and R at Ti plus 1. So Rti plus 1 minus Rti vector, that is this vector. Okay, if it is very small, then it is a straight line. Divide by, then if it is t, r at t and r at t plus 1, then the independent component t varies delta. Anyway, we are not talking about delta. We are talking about delta r. So delta r vector is here, that is r vector at ti plus 1 minus r vector at ti. So that is the line integral of f in this part, only in this part where this is r at ti and r at ti plus 1, where I is a subsection, we have done n subsection. If that is true, then line integral of this part is f vector at ti, f vector at rti, f vector at I, because f vector is changing, vector field is changing as per the t is changing. Now independent variable is t. So f rt vector dot d r ti plus 1 minus r ti. Rti plus 1 minus Rti is a delta R. So that is the line integral along this subsection is f vector at Rti dot, then dot delta R. Delta R is Rti plus 1 minus Rti. So f vector at Rti dot product of braces the vector what results in r ti plus 1 minus r ti, that I can say delta r. if if I do this much change in r, because because there is a change in delta t, so if I divide by, so whatever our job is to find the line integral, the line integral of subsection is over. The function vector field f at f at rti dot product with the section I have taken ti plus 1 to ti, then rti plus 1 minus rti vector, that is the line integral of that subsection. What about if I divide it by delta t? If I divide it by delta t, then I have to multiply it by delta t. Then it is same calculation. R vector at ti plus 1 minus r vector at ti divided by delta t, then I multiplied by delta t, same. But this terminology r at ti plus 1 minus r at ti divided by delta t, it becomes per unit change in delta in t brings how many unit change in r? It becomes a differential. This is nothing but dr by dt. So if delta t is very small, then it becomes dr by dt. Now it is same as whatever we are talking dr by dt. Now if I talk about the full section of the arc, then I have to keep adding all the items. So if I want line integral not in term of t, then it is f at rti dot product with delta r ti, delta r ti nothing but r at ti plus 1 minus r at ti, delta r at ti f f vector field at rti dot delta r ti. Then I have to sum up I equal to 0 to n minus 1. That much subsection I had done. Okay. Now that would lead to f dot dr integration, but dr is drt, not drxy. Now if I divide by delta t, then we saw immediately it turns up into a differential. So now we can call it that it is the line integral is f at rt, vector field at rt dot product of d r by dt, dr vector by dt. Numerator I can keep dt, and this is dr by dt. Dr by dt is nothing but gradient component or differential of the rt. Same thing what we talked that earlier in the earlier session, that if I have a vector field, if this is a circle and if I have a vector field, and I want to calculate vector field integral along the circular line, then we don't have to see the position vector, rather than we have to see the tangential. The tangential vector actually they represent the curve, not the position vector. This is what initially I had taken as assumption, if you remember. The assumption is that if I want gradient vector of a vector field with a curve, then curve tangential vector at each point means the curve, if I calculate tangent at each point, then that results in a vector field again, tangential vector field. So f dot tangential vector field is the line integral, not the position vector field. Position, if this is vector field, that is xi plus yj. Initially we had taken xi plus yj, xi plus yj. If I had taken xi plus yj, then vector field is like this. If field is like this, then what is the line integral along the curve. If this line integral the curve, if I want to represent curve as vector, then that is the tangential line along the curve is the actual representation of the curve in terms of vector. Then this vector field and this tangential line, if you do dot, then it comes as 0. Now it is proved. Now you can see that f in kind of parametric vector, f vector field at any rt dot dr dr vector by dt, whatever comes dt. So dr by dt I can call as r one single quote, double quote, single quote is representation of differentiation. So vector field f at rt dot product of dot product of r quote differential r vector field dt. Actually it is dr vector converted to dr by dt. Dr by dt is r single quote t. So now the vector field along any curve line r, now r is changed to parametric vector rt, then f vector dot r single quote differentiation r on top, if you place a single quote single line the line, then it becomes differentiation. So f vector field dot r r derivative dt, f vector field at rt dot r derivative r derivative of vector r dt. It comes same as what we are talking, that vector field f dot derivative of the path. If I take derivative of the, if I assign the path as position vector, that is rt, then dr by dt, that is the something that we are looking. Anyway, we have given example now for the parabola. So parabola f is, now if it is parabola is y equal to x square, if I take x as t, then y is t square. Since it is passing from origin, then I don't need to add anything out here. Otherwise, if I say it is passing through, if it is passing through 2 and 4, then the parametric vector is 2 plus ti, that is x, plus 4 plus t square j. What is the parametric vector for a parabola which equation is y equal to x square and it passes through origin, means that is the minimum point, and 2 comma 4. If I take x as t, then y is t square. If that is true, then if the position vector of the parametric vector representing the parabola is xi plus yj, then it is ti plus t square j. If it is passing from t 2 and 4, then it becomes 2 plus ti plus I plus 4 plus t square j, because the vector representation of parametric vector, the vector representation of a algebraic equation, parametric vector is the parametric vector what we get plus the position vector through which it is passing. It is passing through position vector 2 and 4, then position vector is 2i plus 4j. 2i plus 4j plus ti plus t square j, that comes as 2 plus ti plus 4 plus t square j. Please watch our parametric vector videos. So now if vector is, now vector is x vector we are talking, the vector field we are talking is minus yi plus xj. If there is a vector field minus yi plus xj, then what is vector field line integral through a parabola y equal to x square from 0 comma 0 to 2 comma 4? That is the question. Now we will solve through parametric way. Then minus y becomes, if I make it passing through origin, then the parametric equation is ti plus t square j. So here it becomes minus t square I plus tj. That is the vector field equation now. And d of the parametric vector. Now, d of parametric vector is d of ti plus t square j. If that is true, then it becomes then I plus 2t j dt. Same thing what we are talking are parametric vector. If we see the calculus, then it is f dot differentiation of r and then dt. Same thing it came here also. So now we have minus t square dt minus t square dt plus t t minus it is minus yi plus xj minus y becomes minus t square I plus tj, that is the vector field. Here d of r vector, r is ti plus t square j, that resulted in I plus 2tj. Now if I calculate add this, it becomes minus t square dt plus 2t square dt. It results in t square dt. Now be careful when you set the limit. Now limit is from, we wanted from 2.4 to origin. This is the what? The line integral direction. The line arc has a direction 2.4 to origin. Then the integration what we are doing f dot dr that is from 2 to 4 to 0 comma 0. Now it resulted in t square dt. If it resulted in t square dt, then if x equal to t, then x is 2 to 0. It becomes t is 2 to 0. So if that is true, then it resulted in t square integration, that is t to the power 3 by 3 from 2 to 0 minus 8 by 3. If it is 0 to 2, then it is 8 by 3. So this is the kind of line integral through parametric vector. Parametric vector where the independent component is only one, that is 3. Now what is the questionnaire now? Questionnaire is simple, that I want the line integral for the circle, okay, where the equation is vector field is minus yi plus xj again, and the circle is x square plus y square equal to a square. For the first quadrant a comma 0 to 0 comma a, what is line integral as far as the independent component t is concerned, not x and y. Okay, so here I can do whatever I did for parabola, or I can take the position vector of a circle as cos a cos ti plus b plus a sin tj. A cos ti plus a sin tj is a position vector of a circle of radius a, where t is independent component and t is radian. In this form, if I do, then what is line integral when vector field is minus yi plus xj, and where the parametric vector is in form of a cos ti plus a sin tj. So this is the questionnaire that need to be solved for the first quadrant, where a is a comma 0, where the first limit is a comma 0 and second limit is 0 comma a. Then slowly we will, if we crack this, then we will move to path independence. Then slowly we will move to path independence, path dependence, and then we will move to much awaited 3 dimensional as far as dx dy dz is concerned, or parametric vector is concerned, how we can solve. So those things are still researchable if we go for n dimension. These kind of mathematics are new, and these kind of mathematics are precious because artificial intelligence and machine learning are technologies has come, where each sample in a data set is nothing but it's a vector. So now it is up to me where each sample is a static vector which has features but it has value. Can I full database? Can I represent it using a vector field? If I am able to represent in vector field, then I can do integral along line integral and so many things. Quickly I can find the prediction, because artificial intelligence is nothing but that whatever has happened we formulate into a some formula in algebraic vector, and then if I set the independent variable or parametric independent variable, quickly I can say that what is the next sample category, what is the future. Okay, so that is where it cracks down. Anyway, we will proceed in the independence of path and slowly we will proceed.